Now we want to look at the bond types. We have three types of bonds. We have ionic bonds, covalent bonds, and metallic bonds. So we're going to pass you through how the bond is formed, the structure, and the properties. Ionic bond is formed between a metal and a non-metal, which occurs by transfer of electrons from the metal atom to the non-metal atom. Covalent bond is formed between a non-metal and a non-metal of the same kind or different kinds. It is formed by sharing of electrons. Metallic bond is formed between metal atoms. Now, in the structures of those bonds, the structure in ionic bond, which forms ionic compounds, the structure is giant ionic structure. The properties of that ionic compound is high melting and boiling points due to strong ionic bonds which require electrons to break. Ionic compound also conduct electricity in molten states due to presence of free and mobile ions. You should also note that in solid state it does not conduct electricity because the ions are firmly held in structure by strong ionic bonds. Now, when you come to covalent bonds, where the nonmetals combine, it forms covalent compounds which have either giant atomic structure or simple molecular structure. Compounds which have giant atomic structure include carbon, silicon, silicon dioxide, graphites, and diamonds. Now, those compounds have high melting and boiling points because of the strong covalent bonds which require a lot of energy to break. The same compounds are solid at room temperature because again of the strong covalent bonds which require a lot of energy to break. Now, examples of simple molecular structure are many, but I may give examples as carbon dioxide, oxygen, nitrogen, etc. Those compounds usually have low melting and boiling points due to weak intermolecular force of attraction, which require less heat energy to break. In most cases, compounds with simple molecular structure are either liquid or gases at room temperature. This is because of the weak intermolecular forces of attraction. Now, when it comes to metallic bonds, which you have said is a bond formed between metal atoms, like I say, sodium atoms or magnesium atoms, the structure of the atoms which form metallic bond is giant metallic structure. Now, metals usually have high melting and boiling points because of the strong metallic bonds which require a lot of energy to break. And then the same metals conduct electricity both in molten and solid states due to presence of delocalized electrons. Other bonds apart from the bonds mentioned above, you have coordinate bonds, also called dative bonds. This one is a type of covalent bond in which only one atom forming the bond contributes a pair of electrons to be shared. Both hydrogen bonds and van der Waals forces are types of intermolecular forces of attraction which occur in covalent compounds having simple molecular structure. Hydrogen bond is usually stronger than van der Waals forces. Both hydrogen bond and van der Waals forces are usually illustrated using dotted line as shown in the diagram. Dotted line? Dotted line. Yes. Of drawing using dot and cross to show ionic bonds. We're going to look at an example of magnesium chloride. Usually the first step, number one, students should do is to first of all write the formula of magnesium chloride so you know how many atoms are combining. Then stage number two, you write the electron configuration of each atom. Atomic number 12, configuration becomes 282. Chlorine atom, atomic number 17, electron arrangement is 287. Now, to draw the bond in magnesium chloride, we draw one ion of magnesium because from the formula it is saying 2 chloride atoms, so we'll have to form 2 chloride ions. 2 chloride ions. Then your next stage is to write a charge for magnesium here, which is losing 2 electrons. The charge is 2 plus. The charge for chlorine is gaining 1 electron. The charge is negative. Then, because magnesium reacts by losing electrons, so we're going to draw the ion magnesium as 2,8 here using crosses. So the first energy level, the nucleus first energy level has 2 electrons. The second energy level has 8 electrons. Then when you come to chlorine ion will gain 1 electron. So if we use crosses for magnesium, we should use dots for chlorine. So we draw the nucleus, the first energy level, 2 electrons, second energy level, 8 electrons, third energy level, we first of all draw 7 using dots. Then 1 electron was gained from the atom, so we put 1 cross. Now when we come to covalent bonds, we said this bond is formed between non-metal atoms of the same kind or different kinds. So it's formed by sharing of electrons. So for oxygen molecule, we have 2 atoms, so we draw 2 circles. One is for 1 oxygen atom, another oxygen atom there. Then next stage, you write the electron configuration of oxygen atom, which is 2.6. And for each atom, you place 6 electrons there and then 6 electrons there. Now for oxygen to attain stability, it has to gain 2 electrons. So for each 6 electrons, you subtract 2 electrons to be shared. The remaining electrons for each atom are placed outside. If one atom use cross, the other atom you're going to use dots. So the remaining 4 electrons, put them outside. Then the 2 electrons which are gained, they are shared inside. 1 cross, 1 dot. 1 cross, 1 dot. Now when you come to